I'm going to show some progress I made on a kind of a side project to the generator tool I'm making. This is an ECM tester, and it allows you to test ECMs on the bench. And it sounds easy, but testing ECM is kind of difficult. And some of the tools out there get pretty expensive. This is one of the signals, or two of the signals it's simulating. That's a cam and a crank shaft waveform right there. You need to simulate those signals in order to get a response from the ECM. You also need to simulate a bunch of other signals, and they all work together to fire the injectors and to do the work the ECM does, whether it's firing injectors, firing the coils, control. So all these, you have inputs and outputs to the ECM, and basically this monitors the outputs and it fakes the inputs. So I've kind of specialized this to target generator ECMs, and actually some generators don't have a full ECM. They might have an ignition control module. We have something called an ultronic ignition, which I have this, and I have all the ultronic ignitions built into here. Ultronic is basically uses a reluctor wheel that's on the crank, and it sees the position where it is, and it'll fire a coil. So basically, the cam and the crank signal are really the hardest ones to make. So I have an editor here, and if you look at, we're producing a signal right now. I'll make this gap go away. So you see that tooth missing there. I can make it bigger. So I can put a bigger gap there. I can make this gap smaller. I can place it in a different spot away from the index. I can put the index here. So I can edit it, or I can take some pre-programmed cam crank correlation waveforms. So on your crankshaft and on your cam, there's a disc, and it basically codes with teeth that these sensors will pick up and create a higher or low voltage, depending on the type of sensor, that the ECM recognizes, and it only recognizes that, and once it sees that, it'll start firing. That's why some cars won't fire the ignition until it sees a proper cam and a crank signal. So just that alone is really helpful, but knowing if your injectors fire, really that's half the ball game, and a lot of times that's all you need to know. Sometimes you'll lose an ignition driver on an ECM or a coil driver. Being able to put a signal in there and measure it on the bench and seeing that all your injectors and all your coils are firing, it can be pretty helpful. So going back to the dashboard here, we have a sensor simulator. So if you look at the injector panel here, actually, let me go to the right, something that would have injectors. So if we go to the injector panel here, we're seeing some injectors fire. I'm putting in just a random signal. I don't have an ECM, so I'm faking an ECM on the bench here. But if you see that 3.2 milliseconds there, so what an ECM does is it looks at a bunch of sensors, whether it's the barometric sensor for your the atmospheric pressure where the engine's operating. It's going to take in the engine temperature, the map sensor. It's going to take in all these sensors, and it's going to calculate based on your fuel trims and your oxygen sensor how long we're going to fire that injector. How much fuel we're going to inject on that ignition, on that cycle. So this gives you the injector on time there. So we can simulate some sensor values here. Temperature. We can simulate our MAF. We can give it a lean signal or rich signal, or we can have it automate, and I can actually make it sweep like an oxygen sensor would. So we can simulate a fake oxygen sensor. Then we can look at the actual, on the injector panel, we can look at a scatter chart, and basically what it does is it calculates, it looks at the relationship between the O2 voltage and the injector on time. It does it for the map and the barrel. So we can see, if we're having some fuel mixture issues or whatever, we can see if the ECM is responding. That's important on diesels. So the other thing, I'm trying to fit this into a short video here. Sometimes you just might have a sensor that's just not reading right. It's improperly displaying the coolant temperature or whatever. So we can simulate the signal, and if it's a J1939 engine, we can look at J1939 values. Now I'm not hooked up to a diesel engine here or any heavy duty. Kohler uses J1939 on some of their residential stuff and light commercial. And we can do automobiles with OBD2. So we can compare our simulated sensor values that we're pumping into the ECM, and we can look what's coming out on OBD, on the onboard diagnostic port. On the dashboard here, you can see on the ECM bench here, so I can put it into accessory here. And shut it off, put it in accessory. Accessory will not fire the cam and the crank, but it'll turn on the fuel pump, or it'll look for fuel pump coming back. Again, I'm simulating inputs and outputs to get a response here, just to show you. And I've also put in we have standalone ignition, but then I've also put Generac ICM, and then if we go to that injector panel, so it's looking at a velocity mixer system, and then we'll do one more. We'll go to ECM config, and we'll go to, what the hell is that playing there? We will go to, let's see, I want to go to like a PSI engine here, and it gives you some good information here for the PSI. It'll show you your coils. And it'll give you some diagnostic information on that. And if we go on the bench, I think the dashboard will show something. Yeah, so that's for the Ultronic, and you're going to see the individual coils, and it gives you, it gives you some data there. So that's the that's my ECM tester. It may go into the Gen Commander Pro, or it may not. But I think it's a pretty useful tool. You can see it gives you all the Ultronic information there. There was one other thing, air fuel solenoid. Oh, the AFS, that's what I wanted to show. So the AFS, Generac uses the air fuel solenoid, and basically it just manipulates the regulator diaphragm. So we can test that on the bench here too, and see if we're changing our duty cycle based on O2 sensor values. So again, we'd come into the sensor simulator, I'd put that in auto, we'd simulate the O2 sensor, we'd go into the injector panel, and then we'd read our scatter plot here based on the AFS and duty cycle of the AFS. And that's about it. We get the live rich lean signal up there. So this is probably going to stay standalone. Some of the features, I might take this and put it into Gen Commander Pro, or not. I don't know yet. So that's that.